Recall that quadratic equations can be written in different forms. The first form we call the vertex form, usually. Second one is the factored form. And the third one is the standard form. Of course, different resources may call them different things, but I'm going to stick to these words. In this video, we'll concentrate on how to get to the factored form, because that form will allow us to see the roots of the equation and then finally the x-intercepts of the graph, or where the parabola hits the x-axis. We're learning how to solve quadratic equations. That means recognizing that we have degree 2. Here we have x squared, x squared, x squared, x squared, x squared. This method, we use the zero product property, and that means once we have an equation written this way, we can apply this property. If a times b is 0, here we have one factor times another factor equals 0, then we can say that either this part of the equation is 0, because 0 times anything is 0, or the second part of the equation equals 0. Anything times 0 equals 0. The zero product property says if the product of two or more numbers is 0, then at least one of the numbers must be 0. The first one must be 0, or the second one must be 0. When the equation is already written that way, it's easy. We can see a product, or in other words, we can see two factors that equal 0. In the first question, we already have two factors. We have a product. We can say that x minus 5 is equal to 0, or x plus 1 is equal to 0. X is equal to 5, or x is equal to negative 1. Two roots, two solutions to this equation. We have two terms at degree 2, and it's possible to solve this equation by doing our square root, both sides, so x is equal to plus or minus 4, as before. However, we can also use the zero product property here as well. If we could somehow write this as a product, we'd be able to apply the zero product property, and that requires us to factor. We know we have an x squared and a negative 16. We're trying to find two values here that end up adding to 0x, because we don't have the middle term. If you think about that, positive 4, negative 4 are the two values that will work. X minus 4, x plus 4. X minus 4 times x plus 4, which we can write in any order. Notice we have a perfect square here. We have a perfect square here. We have a difference of perfect squares, a difference of squares. And a quick way to factor those is you put a plus and a minus and take the square root of both of these and then insert them. We have a product. We can apply zero product property. X plus 4 equals 0, or x minus 4 equals 0. X is equal to negative 4, or x is equal to positive 4. Two answers. Next question, we need to find two numbers that multiply to negative 18 and add up to the coefficient of the middle term. 1 and 18, 2 and 9, 3 and 6. If we make the 9 positive and the 2 negative, that should give it to us. X in the front, insert the numbers. X plus 9 is equal to 0, or x minus 2 is equal to 0. X equals negative 9, or x equals 2. Two answers. Using a visual to factor, we have x squared, negative 18 for sure. These two spaces need to add up to the plus 7x, and the only way that that happens is if we list the factors of 18, 1 and 18, 2 and 9, 3 and 6. 2 and 9 would be it. And we can say that we need a positive 9x and a negative 2x. Our factors are x minus 2 and x plus 9. X plus 9, x minus 2 equals 0. X plus 9 is equal to 0, or x minus 2 is equal to 0. X equals negative 9, or x equals 2. Two answers. Next one, we have a quadratic because we have a squared and we also have a x to the 1. We need to see if we can factor. We need to move all of the terms to the left side by adding 2 and now see if we can factor. We need to find two numbers that multiply to a 2 and add up to the coefficient of the middle term. That's not so bad. Factors of 2, 1 and 2. Make the 3. 1, 2 are the two numbers. We have x in the front, plus 1, and a plus 2. X plus 1 is equal to 0, or x plus 2 is equal to 0. X is equal to negative 1, or x is equal to negative 2. Two answers. Using our area model, we'll start with everything on the left side once again. X squared, 2. We need to find two numbers that add up to the 3x, and that would be a 2x and an x. We have x times x is x squared. We need a 1 there. We need a 2 there. They're both plus. X plus 2 times x plus 1. X plus 2 is 0, or x plus 1 is 0. X is equal to negative 2, or x is equal to negative 1. Two answers, or two solutions. This one needs a little bit of work. We need to make sure everything equals 0. We're going to subtract x squared and add 4x. Subtract x squared and add 4x. We'll have 2x squared minus, what is that? 17x plus 21 is equal to 0. 2 times 21 is 42. We need to find two numbers that multiply to 42 and add up to negative 17, the coefficient of the middle term. We list all the factors of 42. 1 and 42, 2 and 21, 3 and 14. We can stop there, 3 and 14. If we have a negative 3 and a negative 14, that'll work. We'll split this to negative 14x and negative 3x. We still have our 2x squared and our plus 21. Two groups, 2x is common. We've got x minus 7 and a negative 3 is common, x minus 7. In these two terms, we have an x minus 7 that's common and the 2x minus 3 left over. X minus 7 is equal to 0, or 2x minus 3 is equal to 0. X is equal to 7, or we have 2x is equal to, add 3 both sides, 3, divide by 2. X is equal to 3 halves. That's okay, we can have a fraction. We have x is equal to 7, or x is equal to 3 halves. I want to show the area model here as well. We need everything on the left side. 2x squared minus 17x plus 21 is equal to 0. You want to visualize what's happening. We have a 2x squared and we have a 21. We need to find two numbers here that will give us negative 17x, but also give us the 21. A little more complicated. This was the decomposition method for solving. Strictly using algebra, we were searching for those factors, and the factors we got were 3 and 14. We need a negative 3, comma, negative 14. If we put a negative 3 here with the x and a negative 14 with the x here, we'll be able to read off our numbers. So somehow we need the negative 3x here, it'd be a negative 3, and therefore this would be a 2x. And somehow we need a negative 14x, so we would need a negative 7 right there. And that should work. X minus 7 and 2x minus 3. And there it is, x minus 7 equals 0, or 2x minus 3 equals 0, x equals 7, or 2x equals 3 divided by 2, x is equal to 3 halves. Two ways to factor. You choose the method. We learned how to find the roots, but you may be wondering, why are we doing this? We're doing it because it's a good way to find the x-intercepts. What we're doing when we're finding the roots of an equation, of a quadratic equation, is we're finding the x-intercepts of the graph. And I want to show you what I mean by that. Remember what finding x-intercepts means? It means that the y value is 0. If you notice, in 3 of these, we see a value of 0. Right there, and right there. If we want to see what this equation looks like graphed, we could just switch this 0 to be the y and see what that looks like. Same thing here, we can do y is equal to x squared minus 16. And this one, y is equal to x squared plus 7x minus 18. The last two need a little bit of rearranging, and we rearranged this one to be y is equal to x squared plus 3x plus 2. And the last one, we rearranged it and found that we had 2x squared minus 17x plus 21. All right, let's pull these up in Desmos and see what we get. Here are all the graphs, and notice there are a lot of them that are hitting the x-axis. X-intercepts for sure. Just look at one at a time. First one, -1 and 5 x-intercepts. And that's exactly what we found the roots to be. Next one, -4, 4, and those were the roots. -9, 2, definitely the roots. -2, -1, matches the algebra. And the last one, even though it was a little weird, we have 1.5, which is 3 halves, and we have 7. Both of these match up with the roots we calculated. And once again, all of these roots we found algebraically are actually the x-intercepts of the graph.